let's talk about the properties of real numbers. Now, what we mean by properties is what kind of things are you allowed to do with them? A lot of these we already know to be true, but we're actually going to just put some mathematical names on them. The first one is called the commutative property. Let's see. The commutative property. Now, commutative means that you can change the order of something. So think about something as easy as 2 plus 3. Well, 2 plus 3 is 5, but if we were to change the order of that and write that as 3 plus 2, that is also 5. So the commutative property, anytime you're talking about properties, you have to say what the property is applying to. So the commutative property means you can change the order. And what are we allowed to change the order of here? This is addition, so this is called the commutative property of addition. Now the way that we show this is we use symbols instead of numbers. We said that A plus B is the same thing as B plus A. Now what other operations are commutative? Let's see. What about multiplication? Well, 2 times 3 is 6, and 3 times 2 is also 6. And notice, it doesn't matter what order we multiply, so we call this of multiplication. So the way that we demonstrate that is we say A times B is the same thing as B times A. All right, let's see if the other two operations are commutative. What about subtraction? 5 minus 2 is 3, but 2 minus 5 is negative 3. Right? So since the order here changed, we didn't get the same answer, which means it's not commutative. Now be careful. Remember, we tend to think of addition and subtraction basically being the same thing. Notice here we changed the order of the two numbers. Now, if we just change the order of these but kept the sign the same, right? If I said 5 minus negative 2, here the 5's positive and the 2's negative. If I keep the 2 negative and the 5 positive, the answer is still 3 because this is demonstrating addition. However, here this was subtraction because I changed the signs of the numbers. That's why subtraction is not commutative. What about division? That was pretty easy to see. 4 divided by 2 is 2, but 2 divided by 4 is a half. Right, so that definitely doesn't work if you change the order there. So the only two operations that are commutative are addition and multiplication. The next type of property we're going to look at is called the associative property. Now the associative property, kind of what it sounds like, how you associate or group things together. So if I said 2 plus 3 plus 4, now using our order of operations, I can institute an order that this is supposed to be done. By putting parentheses here, this says add the 2 and the 3, and then add the 4. But I could have also taken this and put parentheses here, which says, according to our operation, add the 3 and the 4 first, then add the 2. Will this change our answer? Let's see, 2 plus 3 is 5, plus 4 is 9. Over here, 3 plus 4 is 7, plus 2 is 9. Now notice it didn't matter which order that we associated these things together. So since that operation that we were using there, that's of addition. And here's the way it's written. A plus B plus C is equal to A plus B plus C. The only difference here is we're going to group them differently. On the first side, we're going to do A plus B first. On the other side, we're going to do B plus C. Now, let's see, are there any other operations that are associative? Well, yeah. And it's one that you would think. What if I said 2 times 3 times 4? Again, over here, let's do 2 times 3 times 4. Well, if I did this first, if I did the 2 times the 3, and then multiplied by the 4, if I did the 3 times the 4, then multiplied by 2. Let's see, 2 times 3 is 6, times 4 is 24. Over here, we do 3 times the 4 first, that's 12. 2 12s is 24. So you see, multiplication is also associative. And the way that we write that is basically the same way. A times B then times C is the same thing as A times B times C. All right, one more property here, and this one's kind of the one that stands out on its own. It really doesn't kind of fit the flow here. This is called the distributive property. The distributive property, notice that this one's not going to have of addition or multiplication or subtraction or division. It's just called the distributive property. Technically, this is called the distributive property of multiplication across addition, but we don't write all that. What this says, let's do 3 plus 4. Now notice this one's different because we're combining multiplication and addition. These up here were either multiplication or addition. What this says is if you were to follow your order of operations, you would do the 3 plus the 4, and you would get 7. 2 7s is 14. The distributive property says you also have this option. This says that everything in here needs to be multiplied by 2. So you can do the 2 times the 3 and the 2 times the 4. That should give us the same answer according to this property. That's a 4. So that's going to be 6 plus 8 is 14. Notice we get the same exact answer. So the way we write our distributive property, and it's stuck down here at the bottom, A times B plus C is the same thing as A plus B times, or A times B plus A times C. Basically, we take the multiplication and distribute it across that addition. Now, most of these properties we use without even thinking about it. The distributive property is one property that we actually need to generally say we're going to use this property. These other ones we just kind of use because we understand them. Let's see if we can do this. State the state the properties that are shown. So I'm going to write an expression up here, and let's see if we can see what property it's displaying. So if I said 2x equals x times 2. Now the easiest way to figure out which property or properties are being demonstrated, you want to ask yourself 3 questions. The first question, to get it out of the way, is it the distributive property? Well, to be the distributive property, you have to have multiplication and addition. So this is the easiest one to recognize. Well, I don't have multiplication and addition, so this is not the distributive property. Once you've decided it's not the distributive property, you want to ask yourself 2 questions. Did the order of the things on the sides change, and did the grouping change? Let's start. Did the order change? Well, if you look at the things on the left, we have a 2 and an x, and then an x and a 2. Since the order changed, we're talking about the commutative property. Did any grouping change? Well, we didn't have any grouping up here, so this is just the commutative property. Now, you can't just leave it as a commutative property because we have 2 different ones. What's our operation up here? Well, our operation is multiplication, so it's the commutative property of multiplication. So if I said, let's take a look at this expression here. See if we can determine what property that is. First off, is it the distributive property? You always want to get that one out of the way first. Well, all I have up here is addition, so I don't have any multiplication, so it's not the distributive property. So that one's off the table. First thing we want to check is, did the order change? So let's just move across here. I have an x, a 3, and a 4, an x, a 3, and a 4. The order did not change, so it is not the commutative property. Did the grouping change? Well, I do have grouping symbol this time. On the left, I have an x and a 3, and over here I have a 3 and a 4. So we have different things grouped on each side. So this is the associative property. And of course, here we're adding things together, so it's the associative property of addition. Let's try a few more of these. All right, what property is this demonstrating? Well, if we took a look at this, on the left-hand side, I do have multiplication and addition. Well, did we actually multiply everything on the inside by 4? So did we go 4 times x and 4 times 3, 4 times x and 4 times 3? So this is the distributive property. Once you see that it's distributive property, you can stop. Let's try a couple more. What if I said 2x plus 5 plus 3, 3 plus 2x plus 5. All right, let's see which one this demonstrates. The first thing you want to check is it distributive property? In this case, no. We don't have multiplication and addition across each other. All right, did the order change? I have a 2x, a 5, and a 3. A 3, a 2x, and a 5. So the order did change, so this is the commutative property, and we're adding things together here, so of addition. All right, did the grouping change? Well, let's see, on the left I have a 2x plus 5 grouped together, on the right I have a 2x plus 5 grouped together, so the grouping didn't change. The same stuff is grouped together, so that is just the commutative property. Let's try one more. All right, once again, let's take a look at this. This is not the distributive property because we don't have multiplication and addition there. So let's see if it's the commutative property. Did the order of these things change? 4x, 5, and a y, 4x, y, and a 5. So yeah, we did have an order change. So this would be the commutative property of addition. All right, did the grouping change? On the left-hand side, I have a 5 and a y grouped together. On the right-hand side, I have a 4x and a y grouped together. So the grouping also changed. So not only is it demonstrating the commutative property, it's also demonstrating the associative property. All right, so given an expression something like this, a statement, you should be able to tell what property is being demonstrated. The distributive property should kind of stand out on its own, that one should be easy to see. If the order of the things changed, it's demonstrating the commutative property. If the associative property is showing that the grouping changed as you move from one side to the other. And it can be both, as we saw in our last example.